All right, here's our last video on factoring. We're going to do 6 problems today, and all of them you should already know how to do. However, some of them look very similar. So what I want you to do right now is to pause and try to work out the 3 problems that you see currently. Okay, seriously, pause this video and work out these 3 problems. All right, these 3 should look very similar to you, and what I want to do is just point out some differences so you know which pattern or type of factoring to use. So the first thing that we should always do is look for a GCF. So in my first problem here, I'm going to ask myself, is there a GCF? Is there anything that these 2 things have in common? And they both have an x squared. Remember, to fix that, we're going to divide. So I'm going to get 64, x squared is going to go at the front, and then I'm going to divide to figure out what's left. That's going to give me 64x minus 1. Because this is just a single x and there's no exponent with it, that it tells me that I'm done. So what I have right here is my final answer. On the second one, notice if I think about GCF, these don't have anything in common but 1, which means my problem is going to stay the same. The next thing I want to notice is that this is to the 3rd power, which to me means that I need to check to see, do I have perfect cube numbers? This is where you're going to use your calculator to find the cube root. So if I find the cube root of 64, I know the cube root of 64 is going to be 4. The cube root of -1 is -1. So now I'm just following my pattern. I've got 1 short parenthesis and 1 long one. So I'm going to have 4x minus 1. Remember, those are my cube roots. Square the first, square the last, multiply, and change the sign. Remember, this parenthesis can now no longer be factored out, which means right here is my final answer. All right, last one. It looks very similar to this middle problem, except now this is a square. So again, I'll start with GCF. It's just going to be 1. Because it's square, this is now difference of squares. Which difference of squares are going to give me those conjugate terms where they're opposite signs. So I think, what's the square root of 64? And that's going to be 8. The square root of 1 is 1. So I'm going to have 8x and 8x. And to break apart the -1, I have +1, -1. The only way difference of squares works is if you have opposite signs on the inside here. Remember, those are called conjugates. So there's my final answer. Notice that those 3 problems are all started out very similarly, but the answers are very, very different once you factor them. That's important for you to know. Okay, on this slide, you may not notice that these are similar, but you will here in just a moment. So the first one, I want you to pause and work out. You should notice that this first problem is shortcut. That's because my first number is 1 out here. So I want 2 numbers that are going to multiply to give me 4 and add to give me -5. And if you think about that for a minute, those numbers are going to be -4 and -1. Right? Negative times negative is positive. When we add them, we get -5. That allows me to jump all the way to my final answer, which is x minus 4, x minus 1. Now, if we look at this other problem, we probably need to think to ourselves GCF, but they don't have anything in common, so my GCF is just 1, which means my problem stays the same. Because I have this 2 in the front, this is going to be my bottoms up problem. So I'm going to rewrite my problem, x squared minus 5x plus 4. Well, you may recognize that's the problem that we just did. So you can show the work if you want to, but I'm just going to steal those numbers and tell myself that I know these factors should be x minus 4 and x minus 1. The difference with bottoms up, you need to be really careful. Some of you are forgetting this today. The difference with bottoms up is that you cannot forget this 2 that you took to the end. So I have to go back and divide by 2. So now remember how this works. You ask yourself, does 4 divide by 2? Does that simplify? Yes, it does. So my first factor is going to be x minus 2. Because it simplifies to a whole number, there's nothing to move to the front. My second factor, we want to ask ourselves, does it simplify? It doesn't, and so I still have this denominator, so here I'm going to have to bring the bottom up. So I have 2x minus 1. Notice that even though we did the same kind of mental process in the middle, these two answers are very, very different from one another. So don't forget to add that bottom part back in and divide so that you can get the correct final answer. Last problem. This problem is intended to kind of be a monster. I'm trying to pick something big so I can show you multiple parts at a time. So remember, first step is always GCF. Notice here that the GCF is 3. So I'm going to rewrite my problem now, and it's going to be 2x to the third plus x squared minus 2x minus 1. Now I have 4 terms, and some of you might not be sure where to go from here, but because you have 4 terms, that's going to mean I need to do grouping. So you may want to make a note to yourself if you don't see it right away that 4 terms means grouping. All right, so I'm just looking for what they have in common. If you know how to do this step, please pause and do it on your own, and let's see if we get the same answer. Okay, so I'm to my final answer here. Remember that the first parenthesis is the one that is the same in both sets. The second factor comes from what I've taken out for both sets. There's one piece that I've forgotten from my answer, and that's my GCF. It needs to come down. So there should be a 3 right here. And this looks like it might be the final answer, but we always need to check our different factors. 3 obviously can't break down any further. Right here, in the 2x plus 1 factor, I can't break that down any further. It's already broken down because it's just an x by itself. If I have x squared, I need to check and see, does that break down any further? Well, you might notice that this right here is difference of squares. And I know that because I've got subtraction and I have an exponent of 2, which means that portion breaks down further. So now I'm going to have 3 from my GCF, 2x plus 1, that factor is just, right, these 2 are just falling down. My last factor, my difference of squares here, gives me 2 factors, and they're going to be conjugates. I'm going to have x plus 1 and x minus 1. And the reason I know that I'm done now is because I have x, x, and x. None of those can break down any further. So this right here is my final factored answer. That's all we have for today. Tomorrow, if everybody's got their video done, we will play a game to review.